Hello everybody, my name is Viktor Tarnavsky, and now my talk will be about the ClickHouse. It's a highly distributed database for analytics. Today I'll talk you, first of all, our story, how we get to a place when you have to build your own database for analytics. Then I'll cover up some features, what we have inside ClickHouse and what its strong part of that. And then some details about what inside ClickHouse and why it's so fast and what other features do we have. And then some use cases for you to use ClickHouse and how it can help in your businesses and in your business tasks. This clicker works. Okay. Story. It was a long time ago, and I work in a company named Yandex. Who know what Yandex means? What company? Okay, I'll cover up it a bit. Yandex is a Russian search engine company, and it's quite big. Actually, it's one of the largest internet companies in Europe. It should be the largest one, but I just don't know how to measure that, so I have to say one of the largest. But in fact, we have more than 5,000 of employees all over the world. Also, the main product of Yandex is a search engine, which is the biggest one in Russia. And that's great because, all over the world, it's Google, right? But in Russia, more than 16% of search share, it's actually Yandex. So we have great expertise in machine learning and developing in general. And also we have a lot of data, so we became some kind of specialists in processing big data. We even have our own MapReduce solution, and not even one, so we have like 3. Also we have broad range of different products. It's a B2B and B2C products. They are quite popular in Russia and in Europe and all over the world. For example, let's say Yandex Navi, it's a navigator. It's very popular in Turkey, let's say. And in Yandex, we have a product named Yandex Magica. It's a web analytical solution. And the solution when you have a website and you install web analytical solution inside this website and then see some statistics about how many people do you have, what they do on your website, and kind of that. And Yandex Magica is number 2 in the world, according to external companies who measure that. And what that means is that we have a lot of data. We have millions of websites as our clients. It's millions, it's a lot of websites. For example, in Russia, we have almost all websites as our clients. And we have some huge clients, international, in Europe ones, and United States. And, in technical way, that means that we process billions of events, more than 30 billions of events every day. And also 100,000 of analysts using our interface every day. For that, we need to have a database which is capable of storing such amount of data and capable of analyzing this data on the fly with the speed we require. This is how our interface looks like, just to get you an idea of what is it. So we have a lot of different dashboards and different parameters you can change, some pie charts, some plots, and the segmentation feature, which is crucial here, which allows you to just filter your data and get only a segment of data you require. And what was before the ClickHouse? Yandex Magica is quite old project. It's already about 10 years, I believe. And of course, in the start, it was MySQL. And everybody started with MySQL, I believe, especially 10 years ago. And MySQL was good enough for a start, but it was kind of slow. In MySQL, we had aggregated data. Like, let's say, if you want to see a report about from what region people come to your website, you have a table with the date, with the region, Santa Clara, San Francisco, and stuff, and the numbers. We call it metrics. How many users, how many page views and things like that. And then you just increment this row if you have another people, right? That works, but MySQL is kind of slow and tricky in management, and we have a lot of data. In that moment, that was not so many data, but we already had a scale problem. So we built a Metrage system. It's our own custom aggregating storage, which is just handwritten code to aggregate data fast enough to our purpose. It has a log structure merge tree inside and kind of that, and it was really fast and works well, but here we have this segmentation feature, and that's a problem because if you have data which looks like San Francisco, 10 guys, San Jose, I don't know, 5 guys, you can't filter that because you don't know how many women, how many men you have through these 10 people. That's why that brings us to another approach of not aggregated data. So we decided to, maybe if we just store source data, like raw data, and then just calculate all we require over this raw data, maybe it will be fast enough to work with. And we had some experiments. We built our own system, which is also was columnar and was some kind of basic system to experiment with. It works. It was working, but it had some limitations, but it shows us that it's actually possible to build such system who is capable to analyze all things we require based on raw data. So we built up some requirements about that, about our future system. It should be really fast because we have a lot of clients and our system is interactive. You just filter something, configure your reports, and then people just wait for the answer in the real time. And it should process data in real time, which means that if people come to a website owner have to see this result in, let's say, a minute, or better in a second. So the storage should work simultaneously on insert and on select. It should be capable of storing petabytes of data because we actually have these petabytes of data. And if, let's say, MySQL, we take MySQL and you put in MySQL petabytes of data, you will have, like, you will live in hell because it's just awful. And that's a real problem. Fault tolerance in terms of data centers, in Mother Russia, data center faults. And we had different cases when some excavator came to our data center and blew up a data cable, and then another excavator the same day came to another data cable, and then your data center just destroyed. So in Yandex, we built all our products keeping in mind that data center can fall, and all our products will leave when one of the data centers is falling. So in this database, it's also a requirement, right? And a flexible query language, because you saw what our interface looks like. We have a lot of filters and stuff, so you have to do that somehow. There was nothing in the market in that moment, because even like 3 of 5, it was like nothing in that moment. There was a Hadoop, but Hadoop it's so slow that we can't compare that. The main ideas behind the ClickHouse was, okay, we need a flexible query language. There is SQL, and SQL is kind of standard, and let's take that. It's good enough for us. And we saw some ways of creating other query languages, like, let's say, MongoDB aggregating API, and it's really awful. You can't use that. So we decided just take SQL. It should be linearly scalable. That means that you can scale, you can just add servers, and it will just work. Focused on fast query execution. As I said, our clients are eager to get their results in real time, so you have to do that fast. Real time in both ways, on inserting, on selecting data, and on a design perspective, it was clear from the start that it should be column-oriented solution, because that's the only way how how you get what we want. And we have a lot of different parameters on our data. On our main tables, we have more than 100 columns, and that's a lot. And if you need just a few columns on a select, you need a system which works with only these few columns. You don't need all other columns. Yeah, that's the main idea about columnar stores, actually. Then we started, and this is how timeline looks like. We have created a prototype in 2009, and on 2012 it was in some sort of production, not as a main analytical storage, but as some side storages. In 2014, we decided that we are ready to launch a new version of our product based on ClickHouse, and it was Metrica 2.0. We started to migrate all the data and opened our new interface. And this summer, 2016, we decided that why not open source? It's good enough to other companies to use, and it's good enough. It's too good to only us to use that because we see that a lot of companies struggle with Hadoop or other analytical solutions, or pay a lot of money to Vertica or kind of solutions like that. So we decided that there is a spot for us. And what do we have today? Today, ClickHouse is open sourced under Apache 2.0, so you can use that in commercial, not commercial purpose as you want. More than 100 companies outside of Yandex using ClickHouse in production or in testing, like everywhere, all over the world. We have a quite strong community. I'll say a few words later about that. And it's under active development now. A few words more. Open source. More than 15 people already commit on our main repository from different companies, including Cloudflare, Booking.com, and other companies. You can see this plot of commits. You can see that ClickHouse is actively developing now, and number of people working on that is growing. And what to say? We have more than 2,000 stars on GitHub. That's cool because Hadoop has 3,000, so it's comparable, right? Community, we have a lot of people in different Telegram chats who are talking every day and solving their problems from different companies. Different side projects on GitHub. It's a web interfaces based on that, some connectors, some drivers, and a lot of projects. Our favorite one is Tabix. It's a web interface based over ClickHouse, which allows you to do complicated analysis of your data and different kind of visualization over that. And you can see different integrations with Grafana, Redash, Apache Zeppelin, and so on. Let's talk about features and what is that about actually. Scalable. I already said that it's scalable, but in our case it means petabytes of data because in Yandex we have these petabytes, and cross data center, it works fine. It works out of the box in a cross-region environment. High availability means that you can build a ClickHouse cluster which works with every let's say, number of failures you want. If you want to build a cluster which survives data center fall, you can do that. If you want to build a cluster which survives data center fall and 2 servers fall, you can do that, and so on. And data compression is quite impressive in ClickHouse. Let's say in comparison with the classic Hadoop or row-based approach, in different data you can get the results of 100 times better. It's easy, and the reason is column-oriented storage, because if you store columns, you can compress them better because they usually have the same structure in that. That's really important when you speak about scale, because number of servers you need for your data is amount of money you need to handle this data. Our The biggest cluster we know, it's a Yandex Metrica cluster, and in this cluster we have more than 20 trillions of rows based on more than 400 of different servers. It's really huge. 3 petabytes of data in 6 different data centers. It can survive fall of any of these data center, and up to 2 terabytes per second processed on this cluster. So 2 terabytes each second processed during the queries of the people using Yandex Metrica. What about querying? How you can do selects in that? We have SQL. SQL is the only way you can select data from ClickHouse. Strictly speaking, it's some kind of SQL dialect. There are some differences, but actually it's not so different. There are a lot of extensions and additional features, like approximate functions, functions to work with URLs and regions, and more and more. Arrays supported and nested data types supported on a whole level, on SQL level, on a DDL level, on a store level, and it's really cool to have not just flat table, but a table with a more complex structure. All queries can be done distributed out of the box, so you just don't need to change the query. You can just type another table for that, your distributed table, and it will be done, including joins and other things. And the pluggable external key value dictionaries. Actually, that's my favorite feature. It's this feature means that imagine that you have table with some client identifiers, and you have another table when you have this translation of these client identifiers to a name of this client. And then you want to select just a name of this identifier from raw data. That's when you use join, right? But in ClickHouse, you can add this external dictionary as a key value source, and it can be added from any source like MySQL, any database who use ODBC, from a file from a disk, or even, let's say, bash script. So that's really cool. I'll show you. That's just a simple query calculating weak audience and traffic on Yandex Metrica cluster. You can see that it looks like SQL, right? There is some difference because there is no star here in the count, but you can use it with star, it's okay. And this is an example of using these external dictionaries. We have field region ID, which is a region identifier, and then we want to convert it to just a name of region. So we first of all use region to country function, which will convert it to a country identifier, not some low-level identifier, but to a country. And then use another region to name function to convert it to a name of this region on English language. And both of them are external dictionaries. And if you imagine this query on SQL with the joins, classic joins, it will end, let's say, here, or maybe here. And with these functions, it's just the functions, and you just call them. Performance. Performance is the most interesting part of SQL, of ClickHouse. Sub-second query, here you can see some neat numbers about overall performance. Sub-second query latency looks not so great maybe, but actually we're talking about analytical queries. Each query doing a lot of work and analyzing a lot of data. So actually it's very impressive. In general, it's 100 times faster than Hadoop or MySQL or other typical databases. And also, yeah, some cool numbers, few billions rows per second can be processed on one node. Yeah, as I said, up to 2 terabytes per second in our metric cluster processed like each second, every day. Some benchmarks, so you can just take a look at that. This is relatively old benchmark of ours. Some comparison with the classic systems like Hive and MySQL. You can see that ClickHouse in general like 100 times faster. The set of the queries here is analytical queries of Yandex Metrica, so it's quite general analytical queries. And there are just a few synthetic ones. Here we have some real competitors, some commercial solutions to analyze data, Vertica or InfiniDB, and you can see that ClickHouse in general like 5 times faster. More details, you can see the link here, and we have a great comparison tool to see how different queries work. Some more modern comparison. This is comparison by Percona, actually, from a Percona blog. Comparison with the Spark and MariaDB column store. This is a great comparison with the huge amount of different details about data compression and so on. But you can see that ClickHouse is just faster, like 10 times maybe, than Spark or column store. There are different other benchmarks. Say a benchmark from Mark Litvinchuk, who put data from a New York taxi. This is nice data set. There is 1.1 billion of rows, and also other one by Percona. So take a look at that. They are interesting. This is an example how ClickHouse actually works. It's a console client. You can see how data is analyzed, and this is a queries accomplished on our Yandex Metric cluster. So hundreds of servers, billions of gigabytes, and you can see some performance numbers here. This query is accomplished in less than a second, and the speed was like 16 billion rows per second and almost 100 gigabytes per second. So that's a lot, right? Interfaces, how you can work with that. You saw a console client. It's quite useful and very easy to use. Also, the main interface is HTTP, so you can just use that from any client, from any language. We have JDBC driver and ODBC driver in beta, both open sourced, so easy to use. And also community already prepared different clients for different languages. You can see a list here. I don't even know what Julia is, but Alexey said that it's important, but I don't know what it is. So you can see that all general languages are covered. For Python, for example, we have like 3 clients or 4, like that. What do we have inside, and what design decisions we made? And first of all, I want to answer a question why it's so fast, because that's the main question we have about the speed. The first reason is code. A lot of work done on the code base, because there was a reason for that. We had the Yandex Metrica, and Yandex Metrica had to work somehow. And to make Yandex Metrica work, we need a solution as fast as we can do. So the main points here is vectorized query execution, which is very important. It works very simple. If you analyze your data row by row, it's really slow. But if you work with the vectors of data, let's say you want to summarize some numbers, and if you take each number and just plus to some accumulator, it works okay, fine. But if you do a vector summarizing and use some neat vector functions, then it works extremely fast. Low-level optimizations and specializations, I'll just give you an example. You know group by, right? Just a group by in SQL. And in ClickHouse, there is 17 different ways to make a group by. And one way is the way how it will be done is chosen based on your request and your data patterns and how the request is looking at. So that's just an example of specialization. And there is a lot of different work, like different functions to accomplish a unique number, calculate a number of unique numbers of something, and so on. Every piece of code, every feature, when it is done, is covered with the performance tests. And there is a lot of work. Okay, we can't just make this feature. We need to make this feature as fast as we can do. So you can say that about any function in ClickHouse that it will be as fast as it can. If not, just tell Alexey and he will make it fast enough. Data. As I said, it's column-oriented, and in performance it's very important because you just read only the columns you need in your request. Merge tree, in general, it means that your data is sorted by primary key and keep being sorted during the inserts. And that means that you also read only the data you need, and you read that not like a random 6, but on a linearly from disk. That means that ClickHouse works great on the hard disk drives, and actually our Metrica cluster works on the hard disk drives, and that's okay. ClickHouse is optimized for that. In terms of processing data, all this data processing accomplished as close to data as possible. Let's say we have a distributed query, and this distributed query works on 100 of servers. We do so much work on the difference of servers where data is as we can, and then we transfer some prepared data to initiator and then just merge that. Features. Also, there are some features which make ClickHouse faster than it. Then you can just type a query. Let's say it's sampling. Sampling, it's an ability to, if you have a query and it's not fast enough for some reason, let's say you have a lot of data, then you can use sampling and do your query on 10% of your data or 1% of your data. And it will be 10 times or 100 times faster. That works out of the box. Approximate functions, there are some functions which work faster but have some mistake in that, like let's say 1% or something like that. In sometimes it's very useful. And there is a lot of performance parameters you can use on a request level. So let's say number of threads you're using, number of cores you're using, or kind of that. Scalability and fault tolerance. We have our Metrica cluster, which is big enough, and in Metrica cluster we have literally hours of downtimes during all this period. It's about 3 years maybe, and that says a lot, especially when we're talking about Metrica, because on Metrica we deploy the most fresh version of ClickHouse like every 2 weeks maybe. Cross data center, as I said, it survives data center fall. Also, asynchronous replication helps us in that because it works just faster, right? And eventual consistency, which means that your data will be consistent eventually. This is how Yandex Metrica cluster looks like. So here we have different data centers and the different shards, and we have replication factor 2 now. That means that we have like shard, this one, and another copy of the shard in a different data center. Well, that's how in general looks a ClickHouse cluster. You have different shards, and for each shard you have a copy set, and this copy set is placed in different data centers like that. Use cases, how it can help you. And I want to start with the wrong cases when you should not use a ClickHouse. First of all, ClickHouse is not an OLTP storage. So if you need a transaction storage like MySQL or Postgres, just use MySQL or Postgres. That's totally fine. It's not a case for ClickHouse because we do not have transactions in that. It's not a key value store, so if you want to store documents or just a super fast key value pattern, just use Redis or MongoDB or kind of that systems. And if your data is modifiable, so you modify your data a lot, also don't use ClickHouse because it's not a case for ClickHouse. ClickHouse is generally works best on logs or some non-modifiable data. Best practices. So when to use it? If you have not so many data types, different data types, but they have a lot of parameters in that. So you have a few wide tables in that. That's great for ClickHouse. If you have very structured data, so not a JSON, but structured data with a defined schema and defined data types, then ClickHouse is great in that. When your query number per second is low, I mean, like, let's say 100 per second is low enough. 100 per second is our cluster, like that. Then it's fine, but this query can do a lot of work and can handle, can read a lot of data from disk. When you have huge amounts of data incoming, that's important because actually not so many systems can handle a lot of data incoming in there. Let's say MySQL, a lot of systems, they just break when you need to put somewhere this, in our case, 30 billions of events every day. And actually, if you have petabytes of data, you don't have too many choices. You have a Hadoop, but Hadoop is really slow on analysis. You have some different options, and ClickHouse is one of them, one of the few. So typical use cases, let's say advertising network data, RTB, or web app analytics, they are kind of the same because it's logs of some events of people doing something. That's a really great case. A lot of companies using ClickHouse for that if they work in advertising business. E-commerce, telecoms, logs, online games store their events in ClickHouse. It's quite popular. And also sensor.data monitoring or messaging. It's also very interesting because there is a lot of data usually and you don't modify them, but you need to analyze them somehow. There are some unusual applications for ClickHouse we found on the internet. Some blockchain search and analytics engine. You can just go there on a web interface and found some blockchain transactions, and it's based on ClickHouse. Evolutionary generics and genomics. Actually, I didn't understood what they're doing, but it's something about genome, and they're doing find some copies of that of another genome, also based on ClickHouse. And CERN is using ClickHouse on their experiments in some places. CERN is actually have quite a lot of projects with Yandex, so we have some interactions. So for you, I recommend a few simple cases. First of all, it's log analysis. It's really simple. You can just, let's say you have some backend system with the logs. So you can just upload them to ClickHouse, and then already you will have incident reporting. You can analyze what you people doing there. You can look for anomalies and kind of that. And it really can be done in a few hours because ClickHouse is really simple to install. You just install package, run it, and that's it. It's not like a, let's say, Hadoop, when you have to be a Hadoop specialist or PhD on Hadoop installations and kind of that. In-house analytics database is very popular case for ClickHouse when you have some production database, let's say MySQL or Postgres, when you store all the business data. But for analyzing them, it's not so convenient because it's usually slow. It optimized for a pattern from your web system, not from analytics, right? So you can just copy all your data for ClickHouse and build some process who copies this data to ClickHouse, and then you can do any analysis you want, also incident reporting, searching some people patterns or kind of that. So overall, ClickHouse open source database which can be used by anyone, linearly scalable, capable of storing petabytes, blazing fast, really faster than everything I work with. SQL dialect actually with a lot of different extensions, and with a strong community now, with a lot of projects in that. How to start? We have a nice tutorial which you can try, and they take take just a few hours to understand you how it works, the already built-in datasets. You can ask anything on our mailing list, our GitHub project. Telegram chat is very popular. There is also activity in that and questions and so on. And more information you can find on our website, clickhouse.yandex. It's not a mistake. We actually bought Yandex domain. So looks like that. That's it. Thank you. Any questions, guys? Also, we have Alexey here. He is the head of development of ClickHouse. So we can answer you, I believe, anything you want. How data is distributed on different nodes, right? Alexey, want to answer? I'll give you a mic. One, two, three.
There are different schemas how you can distribute data between nodes. In this case, you could just use random distribution. So your data goes in equal parts to different shards. Or you could use hash-based distribution, and it could be advantageous if you frequently do some kind of joins. For example, if in your query you do or join something by user identifier, it's better to sort your data by hash of this user identifier. And then ClickHouse will do this join locally because your data is co-located on your node.
So there are a lot of options, actually. You can choose some of them.
So if you randomly distribute, so the query would go to all the nodes?
Yes, distributed query will be processed on all shards.
And it will, in general, works faster on according amount of times. Like if you have 100 of nodes, then it will be 100 times faster than if you have one node.
But it will not scale for many simple queries. If you have many very short queries, sometimes you need to apply some domain-specific sharding schema.
Yeah, we have this case in Metrica because we have a lot of clients, and most of our clients are small. So if we distribute all our clients, we will have much higher query per second or request per second for a server. So we use different sharding schema depending on the client. Most of the data kept on disks, on hard disk drives. ClickHouse actually do not use RAM as a buffer, explicitly, but just use it as a file system cache.
But then it will be bounded by the random soup.
That's why ClickHouse is based on merge tree, and log structure merge tree systems allow you to read your data linearly, not just random sticks.
You organize it by one way, right? Not two.
That's true. That's true. Okay, answer.
ClickHouse is constantly maintains data locality on disk by constantly reorder data. When you insert new data, it forms a part of data ordered by primary key. When you insert another bunch of data, it's another part. And that part are merged in background. Just like merge tree, you know. Just like
the indexes are on RAM, right? So the percentage of the indexes.
Yes, the index always sits in RAM, even if you have more than a trillion rows per server. There are cases when we have. Because we have sparse index in data ordered by primary key. We just address not every row, but every n row. For example, every 1,000 rows. And we could just read some range, maybe with expressive thousands of rows, but it doesn't matter.
Yeah, because it's hard disk drive.
Because analytical queries read millions rows or billion rows in each query.
Of course, feel free to ask.
What is the primary key? Is it time-based?
In general, actually, it's you can just use any primary key you want. But in general, we recommend to use time at least somewhere in the key. It's a first part usually, because usually all the data is time-based. If you have events, they usually have a time in that. And for if you have time in the index, then merge tree will works better, because you will have some parts in the end which are updated, and then you have all other data from the old which are already merged. So it just works better.
Just for example, in Yandex Metrica web analytics system, we have complex primary key that is tuple of site identifier dot then date and next user identifier. So you might quickly read data for some website, for some range of dates for that website. And if you want to read data from any website, it's also possible. And sometimes primary key works even if you have conditions only by second component of primary key. If some website is large enough, you will read sub-ranges for specific data.
So if you load data not in order, then you reorder it?
Yeah, it will be reordered.
Data in the background or during the insert?
In the background. And this is the main case for ClickHouse, because very often and typical in web analytics, you ingest data almost ordered by time. But all websites goes in random.
Yeah, so data is reordered then.
When you need to read this data, you often read for specific websites. So data must be reordered. And we cannot reorder on insert because it will be too expensive to insert in random parts of the disk. And we cannot reorder in select because we cannot do match 6.
So during the time of the reordering, the data is available, or you wait until?
Oh, of course it's available.
Data is available. We use multi-version concurrency control. So select read from snapshot of data without locking. So
Yandex Metrica system works 24/7, like for 3 years already, and it's inserting and selecting simultaneously anytime. Okay, any more questions? Of course.
You mentioned like these dictionaries that could come from different data sources like MySQL.
Right.
So if you modify the data in MySQL and you run a new query in ClickHouse,
It will be modified. Okay, that's about external dictionaries. So these external dictionaries, yeah, the data in MySQL can be updated, and it will be updated in the query result also. There are some options about caching. For example, you can use cached query, which just upload, let's say, a snapshot of the data from a database and then just use it for a performance reason. But there are some parameters which you can set to update this data, let's say, each minute. So, yeah. In that way, the data can be updated, yeah. Right. We actually use that for this case because client names can be different and can be changed because client came and just changed her name, but client identifier stays the same for the whole system. Okay, any more questions? Thank you, everybody.